let's talk about that plane problem. This one's really similar to the one that you have on your quiz. It says, a plane traveled 1,100 miles each way to Cairo. The trip there was with the wind and took 11 hours. The trip back was against the wind and took 22 hours. Find the speed of the plane and the wind. Your homework question only asks for the speed of the wind, but it's so easy to find both, so we're just going to look at both. Now, there are multiple different ways of doing this, not only solving this problem, but then there's different approaches of using algebra to solve this problem. First off, you could do it by graphing. You can make the equations for this, like set up the equations. You can go to Desmos. Now you know how to do that and like be able to type in the equations and solve this by graphing. You do want to be able to solve it algebraically though. And since this is a linear equation, you know what kind of form linear equations come in, right? They come in like y equals mx plus b, my favorite slope-intercept form. And so you can solve linear equations using the substitution method. And you can also solve them using elimination. I personally, my favorite method is the substitution method. I usually will default to that. My brain really likes this method. Elimination method can get a little hairy for me. So you remember elimination method. It's something like if you have 2x plus 3y equals 10, and then negative 2x plus 5y equals 50, something like that. And then you want to make sure that between one of your variables, either the x or the y, in this case it's the x, one of them is the positive number of that many x's and one of them is the negative version of that many x's. And then when you add them together, one of the variables eliminates, right? Then I cancel that out and I get 5, 8y equals 60. And then it's really easy for me to solve for y. In this case, the elimination method is going to be the best method to use. So this is the one we're going to do for this equation. And then you could always go to Desmos and double check your answer. Like once we get our equations, plug them in and use Desmos as a check. So what do? I'm going to erase this. There's always more than one way to solve a math problem. So many of you might have gone a different route. I'm going to show you 2 different ways that I thought of to do it. If you think of a third way to solve this, that would be awesome. I would love to hear it. Or maybe even another variation. So I'm going to use elimination and I'm going to set this up. So first I'm going to look at my info. So like step 1, I'm going to think about this problem, which is like my important info. And then also eliminate like extra things that they give you, because a lot of the times in story problems, they'll give you numbers that you don't even need to solve these problems. Anyway, I didn't do that with these, so you don't have to worry about that. So the plane travels, it's 1,100 miles just to go one way, right? So each way. So it starts somewhere, it goes 1,100 miles one way, and then it's traveling 1,100 miles back. So that's really important. And then with the wind, it is 11 hours. Against the wind, it's 22 hours. So one way to look at this, or one way to set these up, So I'm going to make my plan. Oh, and also probably one of the most important things to note is, what are you solving for? They want the speed of the plane and they want the speed of the wind. So we need to know like what we're going to find, right? So important information. So step one, find the important information. And what are you solving for? What you're finding. That's it's a common problem. This is one of my problems. You know, maybe you're working through a math problem and you go off on a tangent. You find some pattern somewhere. You go off on a tangent, and then by the time you come up for air, you've forgotten what the overall goal was of why you sat down to like work on this anyway. So, you know, if that's ever happened to you, it's fine. Maybe you're a potential future mathematician. So your plan is, you want to like figure out like, what do you need in order to solve this? And for this, which you physics people out there, you already know, I need an equation that puts together uh, time and distance and speed, right? So if you take in physics, you know that distance equals rate times time. And even if you haven't taken physics, like you would kind of think about that, like, you know, you drive your car at 55 miles an hour on the freeway, and you want to know like how far have you traveled if you've gone for an hour, right? You can figure that out. You take your rate, you multiply it times your time. 55 miles an hour times 60 minutes is how far you've gone. You can use different variations of this, right? So since I'm solving for the speed, that's my rate, you could solve this for rate. You just divide both sides by t. Oops, I did a 6, that's a t. Divide by t, and then you could see it as the rate equals distance over time. Either way you want to look at it, that's totally fine. I'm just going to do distance equals rate times time, because I avoid fractions. They trip me up. So if distance equals rate times time, let's just see if we can set up like two equations, you know, one for the trip there and one for the trip back. So that's my plan. I'm going to set up two equations. One of them is going to be the trip there, and the other one's going to be the trip back. And I also want to define my variables. I'm going to use P for the speed of the plane. Plane's speed. And then I'm going to use W for the wind speed. Okay. Nice and pretty. So distance equals rate times time. Let's look at this. So trip there. Distance equals the rate in this case is going to be, well, I'm just going to be like, okay, I'm just going to leave some parentheses for rate really quick. And how long did it take? With the wind was 11 hours. Okay, so this one's 11 hours. So for this equation, I am looking at my rate, and with the wind is going to be both the plane speed and the wind speed working together, right? So the plane's moving however fast it moves, and the wind is pushing it along with that. And yes, there are lots of things going on. There's drag. I mean, what's your elevation, right? Like there's all kinds of stuff. Like going on with this, but in a simplified theoretical math linear story problem, the rate is going to be both the plane and the wind working together with each other. So this is going to be plane and wind. That's going to be my rate. They're together. So then the trip back, I'm going to say trip there. My trip back on the way back, everything's still like they're still going 1,100 miles. And it's taking them 22 hours. This time though, you've got the plane speed, which is the same. This plane's just coasting at a constant speed, which is another thing that's not exactly true, right? It's got to accelerate from the beginning, get up to its constant speed, and then that fluctuates, right? Turbulence, all that stuff. And then it's got to slow down when it lands, right? So when it actually stops, like, anyway, got to decelerate. Okay, so, but this time the wind is working against it. So we're going to say, like, we're subtracting the speed of the wind, right? So the trip back is this equation. Now, from here, you can choose to, you now have two equations with two unknowns, okay? You have your choice. You can go to Desmos, you can graph them and see where they cross. That'll show you your answer. You can use substitution, which is usually what I use, where I would maybe distribute this 11 times the W and 11 times the P, and then I would go through and I would solve one of these for P, and then whatever P equals, I would substitute that back into the other equation, right? In this case though, there's a really nice, pretty trick for elimination because we already have a positive W and a negative W. So if I set these up right, then when I add them together, like over here, they're going to line up with each other and one of them's immediately going to eliminate, and then I'll only be one step away from finding the other variable, which will be the P, the plane speed. So I want to set these up so that when I write them one on top of the other, that these just cancel and they're all tangled up in these parentheses. So normally you would think of, or at least I would think of, like distributing this 11 through both of those, but then you'd have like 11W, and then over here you're gonna have negative 22W, and then you have to find something to multiply each of those equations by so that their coefficients are the same, but positive and negative. It's a hot mess. The coefficients are already the same, except this one's +1 and this one's -1. So I can just undo this multiply by 11, multiply by 22. I'm just going to divide both sides by 11 here. And then 11 cancels, and I'm left with P plus W. And I don't need the parentheses anymore because they're not being multiplied by that 11 anymore. And then 1100 divided by 11, I had a brain freeze on that one earlier today. That, I'll never forget, is 100. And then the other one, if I divide this by 22, both sides, then the 22s cancel and I'm left with P minus W on one side. And then on the other side, 1100 minus 22, which is double 11. Okay, so now I have two simplified equations and they are set up for elimination. Really beautiful, really beautiful. I am just going to elegantly add them together. And when I do, W minus W cancels. P plus P gets me to 2 P's, and 150 is 150. And then I'm one step away from solving for P, and P equals 75. Oh my gosh, it's glorious. So the plane speed is 75 miles per hour, and then really easy to find the speed of the wind in this case is I can come up to, you can use any equation you want to plug in 75 for P. I'm not going to use either of these because those are a lot more complicated than these two are. I'm going to say 75 plus what gets me to 100. Oh, 75 plus 25 gets me to 100. So 25 miles per hour is the speed of the wind. Gorgeous. But what if you thought about this just a different way? Here's another way to solve this. Again, I have distance equals rate times time. I could also use, you know what, I'm going to try this. I'm going to try using the fraction one because that's what I want, right? I want to find the rate. That's what I'm going for. I want to focus on the rate. So rate equals distance over time. So whatever the rate was on the way there, that is going to be, it took me, I traveled 1,100 miles. And it took me 11 hours. Okay. And notice that this is like 1,100 miles and this is 11 hours. This is miles per hour. That better be miles per hour for a rate. And then so 1,100 divided by 11 is 100. So my rate there is 100 miles per hour. And then my rate back is my distance divided by how long it took me. And so my rate back is still, well, it had better be 50, right? We already solved this. Okay. And then again, you're setting these up again, right? But now you've just like found the rate there, you found the rate back. Now we're just going to set these up into these equations and find those. So my rate there is 100 miles per hour is my P plus W, my plane plus the wind working together, and my rate back was 50, my plane and the wind working against me. Okay. And then you can use elimination again. You could put these on top of each other. The W's cancel out, just like we did over here, and it's nice and pretty. I generally really like substitution, so I'm just going to use substitution here. If I solve this for P, I'm just going to add W to both sides. And then P equals 50 plus W. All right, great. So if P is 50 plus W, then right here, I'm going to plug in 50 plus W. Right, and then these things just still come down for the ride. Those don't change. Since I'm adding here, I put parentheses there. I always like to put parentheses just so I don't miss anything because P is like a lot of stuff, or at least it's 2 terms instead of just 1. But now I realize I don't need the parentheses because I'm just adding. So it doesn't matter if I write them or not. I'm just going to combine like terms. W plus W is 2W. And now I'm just going to solve for W. So minus 50. Looking familiar. Divided by 2, divided by 2, and W now equals 25. I was really hoping I'd get the same answer, right? Like I hope I get the same answer. And then now I'm going to take W and I'm going to substitute it back into some other equation to find P. So I'm just going to substitute in that one because it's nice and pretty and easy. So 50 plus 25 is P. So 75 miles an hour is the plane's speed. So there's two different ways to solve this problem, but basically, like the best things to kind of look at are, oh, and so this was my, so there's two ways to solve these problems. It still requires the same steps that you're going to take, and that's for any problem in math, or a lot of problems can be solved this way in life as well. You're going to think about the problem and you're going to figure out what is the important information and what is it that you need to find the solution to. You're going to make a plan, right, where you're going to figure out like what kind of formulas do I need. I realized this was a linear equation, things like that. And then you're actually going to solve it. Step 3 is solve. Execute the plan, right? And then step 4 is look back. And that's where you check your answer or see if your answers make sense. Sometimes when you're solving things, you can't find another way to do it and you don't have an answer key and you're not sure whether or not your answers are right. So then you're just asking yourself, is this a reasonable solution, right? I mean, I would look at this and go, no, 75 miles an hour, that plane's not going to fly. So if I was legit doing this for a real plane, this would worry me very much. We can also look back though. I would suggest you go to Desmos and try graphing a couple of different versions of these equations, right? Like graph this one, but make this X and Y. So graph this just as it's written here and graph this just as it's written here. And then also do the 100 is X plus Y, and then the 50 is X minus Y. And you'll notice, and both of those graphs, like they'll always cross at the same values for W and P. It's really kind of fun, kind of interesting. So think, plan, solve, look back, and good luck on that plane problem.